This lesson is on surface area spheres, and we're also going to look at similar solids and the ratios of them. Number one would like to have the surface area of a sphere with a radius of 3.7 and use 3.14 for pi. The formula for surface area of a sphere that you might want to write down on a card or somewhere to keep handy is 4 pi r squared. Plug in the radius 3.7, do the math on it, it's 171.9. So it was 4 times 3.14 times 3.7 squared. There's a squared key on your calculator. It is over here to the corner of the 7 and up, x squared. So just put it in. So 4 times 3.14 times 3.7 squared. Enter. And you get the answer. Next one, they would like the volume of a sphere. The volume of a sphere formula is 4/3 pi r cubed. Another one that would be good to have written down, ready to go for when you do your assessments. They gave us the diameter this time was 11.8. So the radius, which is what we need for our formula, is half of that. So divide by 2 and you got 5.9. So 4/3, again, you can put that all in your calculator really quick. So we got 4/3, 4 divided by 3, times 3.14, times 5.9 to the third. So use the caret key. And you get 859.8534153. Anyway, the caret key that I just used is above the division symbol. So I did caret 3, 5.9 caret 3 to get that answer. Number 3 is a story problem. Again, they like to call story problems now on Common Core modeling problems. Modeling is like a code word for story problems. Melissa's company makes solid balls out of scrap metal for various industrial uses. Her current task is to make a batch of aluminum balls with a radius of 4.5 inches. If she has a total of 76,302 inches cubed of aluminum, how many balls can she make? Use 3.14 for pi and do not round your answer. Again, volume is 4/3 pi r cubed. They gave us the radius was 4.5, so plug it in. So when you do that on the calculator for one ball, this is one ball right here, 381.51. And then they want to know if that's how much aluminum we have. How many balls can we make? So we divide the total amount of aluminum by how much you have for one solid ball. And shockingly, it comes down exactly to 200. So 200 is the answer on that one. Number 4 says, for each pair of solids, determine whether they are similar. If they are, give a scale factor of solid 1 to solid 2 in simplest form. So the first one here, letter A. So up here on top, I wrote it out for you. Similar solids have the same ratio for all corresponding sides. So here the heights are corresponding sides, so 24:9. When I reduce it by dividing by 3, I get 8:3. The radiuses, or radii, are 4:3. Notice those are not the same number. They're not equal, so it's not similar. All corresponding sides have to be equal, and those are not equal. Letter B. Same idea. Here we have the ratio of the heights are 15:21, which when reduced by dividing by 3 is 5:7. The sides of the rectangle here are 8:18. See, 8:18, which reduces to 4:9. And these other sides are also 4:9. So the sides down here are both in a ratio of 4:9. But the heights are not 4:9. So because of that, they're not similar. All the numbers need to be exactly the same, and they're not all equal. Two of them are 4:9, but the third one was 5:7. For the next one, it says we have cylinders. So on the cylinders here, we have diameters are 5 to 6, and the heights are 10 to 12. When you reduce 10 to 12, it reduces to 5 to 6. So the ratios of all the corresponding sides are the same ratio. They're all 5 to 6. So the scale factor is 5 to 6 because those were both the same. So this was the first one out of the 3 that had the same ratio for the sides. So 5 to 6. Number 5, it says a designer builds a model of a truck. The finished model is exactly the same shape as the original but smaller. The scale factor is 3 to 11. So since they are the same but smaller, what they're trying to say is that they're similar. So that would mean all the sides have the same proportion of 3 to 11. If you want to talk about area of it, what you do is you take your sides and square it. Kind of like, think about it possibly as being a box. We got the one to the other one is in a ratio of 3 to 11. So this one, we'll say they're squares. So that side's 3, so this is 3, 11, 11. So the area of the one to the other would be 3 squared to 11 squared. That's how come you want to square the scale factor to have the ratio of the areas. You have to square them. Likewise with volume, if you were going to add a third side here and make a box, it would have a height of 3. So the volume of it would be the area of the base times the height. So it would have been that 3 times 3 and then times the height of 3. So 3 cubed. Likewise, the volume of this box would be 11 by 11. And then it would have a height of 11 also. So the volume of that would be 11 to the third. So if you're given the ratio of the sides, you square it, and that gives you the ratio of the area. You take the ratio of the sides, you cube it, and that gives you then the ratio of the volume. And so what's the ratio of the width? Well, width is a length, and so that's just the base scale factor of the sides. So the base scale factor is a ratio of lengths. Now, Alex didn't have you do anything more complicated going backwards, but sometimes the problem will give you like the ratio of the volumes. So going backwards to go back to what the scale factor is of the lengths, you're going to have to go backwards and take the third root of it. So instead of doing it to the third, you're going to do the third root of 27. The cube root of 27 is 3. The cube root of 1331 is 11. So you always got to go back to the scale factor. Likewise, if they would have told you the ratio of the areas is 9 to 121, going backwards, taking the square root of it instead of squaring it, square root of 9 is 3. The square root of 121 is 11. So it's always about going back to the base scale factor, just like when we were doing the 30, 60, 90 triangles. I told you it was all about the short side. You've got to get the short side first. And once you have the short side, you can find the longer leg or the hypotenuse. Same thing on the similar figures problems. You have to go back to the scale factor or the length of the sides, and then from there, change it to volume or change it to area. Number 6, we have 2 similar cylinders, and they have diameters as shown down here. If the surface area of the cylinder on the left is 216, find the surface area of the cylinder on the right. So these 2 cylinders are similar in the ratio of 6 to 5. Letter A wants to find out about the missing area. So the left to the right was 6 to 5. So if we're going to do area, you got to square that ratio. So now it's area. And they said the one on the left was 216. One on the left was 6. So match them up. Put the 216 on top with the other one that was on the left. And then cross multiply and divide, you got 150. Letter B wants to know about the height of the cylinder. Well, if they're talking about height, we don't have to square it or anything. That's just the scale factor, which was 6 to 5. We had to square that one because it was about area. This one's not about area. It's just about a length, so leave it 6 to 5. And they said, well, what about the one on the left, which against the one on the top? The one on the left was 6. So on the top, 36 over the right side, x. Cross multiply and divide, you get 30. Letter C wants to talk about volume. Well, if you're doing volume, you got to take your scale factor to the third power. And they said the one on the left was 432. So again, you're going to cross multiply and divide those numbers. So doing that on the calculator here, I would do the side on the right here. So 5 to the third, so 5 caret 3, and then times 432. I hit equals, so that's the right side, and then I got to divide that by 6 to the third, and you get 250. So 250 centimeters cubed. Number 7, a gift shop uses 2 sizes of boxes for presents. These boxes have exactly the same shape. The smaller box is 16 centimeters long, and the larger box is 18 centimeters long. If 1,920 centimeters squared of wrapping paper is needed to cover the smaller box, how much wrapping paper is needed to cover the larger box? So they said the same shape. Again, that's saying that they're similar. If they're similar, then the ratio here, 16 to 18, is the scale factor. If you wanted to, you could reduce it. You'll get the same answers out of it. Let's see, they both divide by 2, which would make 8 to 9. So you could put 8 to 9 squared on both of them. Again, you'll get the exact same answer. I didn't bother reducing it, though. I just left it 16 to 18. And they said, though, if 1920 is needed to cover the smaller box, well, the smaller box would be the number 16. So I'm going to put the 1920 with it. And then how much for the larger box, which was 18, so that's x. So again, cross multiply 16 squared times x and then 18 squared times 1920. So multiply those together, 18 squared times 1920. Hit equals, and then divide that by 16 squared. And you get 2430. Now the questions start repeating again. So they want the surface area, 4 pi r squared. You're going to plug in the radius, which is half the diameter, so 4.1, and that gives you the answer there of 211.1. All right, I'll talk to all of you later. You have a good night. Thank you. Bye-bye.